The next three problems we're going to do involve quadratic equations in one form or another. The first one, to solve this quadratic, you have three options to solve a quadratic. One is to factor, the next is to complete the square, and the third is to use the quadratic formula. The quadratic formula will always work, so if you don't know either or any of those ways, then I would go with the quadratic formula. I shouldn't say any of them, but if you're not sure if the other two or how to do the other two, quadratic formula will always work. Completing the square will always work, but that is more difficult than on a multiple choice test. I probably would stay away from it. And factoring is the one that will only work if it is factorable. You can try to factor, and if it is factorable, then it will probably take you less time. But if it's not, then you'll be spending more time than you need figuring out it's not factorable. In this case, there are no factors of 1 that add up to 5, so we know it's not factorable. So let's go right to the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And one of the keys when you're solving any quadratic is that it's got to be set equal to 0. So we have that already. And if we look at this, a is 1, b is 5, c is negative 1. So now just a matter of plugging this in and simplifying. So we've got negative 5 plus or minus the square root of 5 squared, and I would put that in parentheses, just in case it's a negative number. That'll possibly mess things up if you don't. Minus 4 times 1 times negative 1 all over 2 times 1. So that's negative 5 plus or minus the square root of 25 plus 4 over 2. And that simplifies out to be negative 5 plus or minus the square root of 29 over 2. And that's how you can leave it. If you need to simplify it, then you just go to the calculator and type it in as it's written. We can also check our answer on the calculator the same way that we've done it. I'm going to rewrite it here to remind us of it. And to show here then that we can do the same storing method that we've always done. So since it's a fraction, I've got to keep the numerator in denominator in parentheses. So negative 5. And I can only do one at a time. So plus the square root of 29 divided by 2. Let's store it as x. And then type in x squared plus 5x minus 1 equals 0. And it tells me it's true, so that answer must be right. And that probably tells me the minus is right as well, since there's nothing else I can do with it. But if you wanted to check it, you'd do it the same exact way, and it would get you the same answer. So you can check it there on the calculator. Let's look at another quadratic equation, and the big difference here, if you notice, is that it's not set equal to 0. So our first job here is going to be to set it equal to 0, which we'll simply do by adding 3 to both sides. That'll move the 3 over. And if you're wondering why I'm not putting those two together, they're not like terms, so I can't make that 1x. Now this one is not factorable either. As I look at it, I can't see how it would be factorable. So we'll go to the quadratic equation. And we have a equal 1, b equal negative 2, and c equal 3. So negative b, so negative 2 plus or minus negative 2 squared minus 4 times 1 times 3 all over 2 times 1. So we get 2 plus or minus the square root of 4 minus 12 over 2. And going back up here, that's 2 plus or minus the square root of negative 8 over 2. And now that we have a square root of a negative number, remember that's an imaginary number. So we're going to have to simplify that, and we're going to do that by pulling out an I. So 2 plus or minus I square roots of 8 over 2. And now I can simplify the 8 because the 8 has a perfect square in it. 2 plus or minus I 4 times 2, and pull that out. So 2 plus or minus the 4 comes out, the 2 stays in over 2. Okay, and then notice that there's a 2 in each of these terms. I can't worry about the one inside the square root because I can only cancel inside with inside and outside with outside. But so this 2 can cancel with the other two 2's. If there was no factor of 2 here, we couldn't cancel at all. There needs to be a factor of 2 in everything in the numerator for the 2 in the denominator to cancel. So those all cancel out and leave 1's. So my final simplified answer is 1 plus or minus I square roots of 2. Okay, and again, I can check this on the calculator. So 1 plus, and now I is down here by the decimal point. So, and notice it's in blue. So second I square root of 2. Let's store that in x. So even though it's an imaginary number, we can still keep it stored. And now I can plug it back into the original equation. X squared minus 2x equals negative 3. Whoops. And I guess maybe it will not work with an imaginary number, so we can't check that in the calculator. Let's see if I can get oh, I can at least get it to choose here that to show that the left side is negative 3. So so even though the equation won't work because of the imaginary number, I can at least get the left side to plug in, and that still tells me that I got the right answer. Right, the third type of problem dealing with the quadratic equation is actually back to the vertex of a graph of a quadratic equation. And we know that the graph is going to be a parabola, and so I'm looking for basically the max or the min point on this parabola. Because this is positive up in front of x squared, I know that the parabola is going to look like this, and so it's going to have a minimum, although it's not really asking minimum directly, but the vertex is that point right there, so it would be the minimum point. To find the vertex, the x-coordinate of the vertex is negative b all over 2a. So that's going to equal negative 12 over 2 times 1. So we have the 1 in front of the x squared, which is going to be 12 over 2. So the x-coordinate of the vertex would be 6, and now I just need the y-coordinate of the vertex. And to get the y-coordinate, well, I have an equation that tells me what y equals, so just plug in 6 for x. So y equals 6 squared minus 12 times 6 plus 10, which is 36 minus 72 plus 10, which is negative 26. So then the vertex of the graph would be at 6, negative 26. That would be the coordinate.